Hi everyone and welcome to Electronic and CNC Lab. In today's video I want to present you a very interesting project that will allow you to create a useful and fun tool by making it yourself. This is a fully built Ethernet cable tester with Arduino MEGA. Arduino MEGA is a very popular prototyping platform featuring an 8-bit microcontroller. Thanks to its numerous input and output ports, it can be used to create custom projects such as our Ethernet cable tester. Ethernet cables are one of the most important components for building a computer network, but how can we know if a cable is working properly or not? And how can we recognize a direct cable from a crossed cable or quickly identify a bad cable? To solve this problem, this tester will help us very quickly give us an answer for each connected cable. And this is where our tester comes into play. The Ethernet cable tester made with Arduino MEGA that allows us to check the functionality of Ethernet cables quickly and easily. The Ethernet cable tester consists of an intuitive graphical interface and a test unit that checks for the presence of signals on the cable. In this way we can quickly find out if the cable is working properly or if there are any connectivity problems. The advantage of our tester is not only that it allows us to check the functionality of our cables, but also provides us with a detailed report of the check by mapping. The result is displayed on a 16 by 2 character LCD display. The tester is very easy to use. Just connect the Ethernet cable to the test unit and in less than a second the result of the check will appear. The graphical interface, the LCD display, immediately shows the test results indicating whether the cable is working properly or not and the mapping of the individual wires on the LCD display. Creating a tool like this Ethernet cable tester can be very rewarding. Not only does it allow us to verify the functionality of our cables and to have a detailed report through the mapping on the LCD display, but it also gives us the satisfaction of having created it ourselves. But let's see what an Ethernet cable or UTP network cable is, which means unshielded twisted pair. This cable is a type of Ethernet cable used for connecting devices in a local area network or an extended WAN. UTP network cables consist of twisted pairs of copper wires. This arrangement prevents the cables from interfering with each other, reducing electromagnetic noise and signal loss. Typically UTP cables are classified according to their category, which indicates the performance specifications of the cable. The most common categories are Category 5E and Category 6, which support transmission speeds of up to 1 gigabit and 10 gigabits respectively for Category 6. But now let's see the types of Ethernet cable that we can test. Then we have as the first category the T568A direct cable, which is the most used in Europe. Subsequently we also see the T568B cable, which is more used in the United States, which is equivalent to the first in terms of performance. They are also quite cheap cables. And finally we can test the cross cable as well. Crossover cable is a cable that is used to connect two computers together. In general, the differences between the 568A and 568B are relatively small, and the choice between the two often depends on installer preference or project specifics. However, to ensure interoperability, it is important that both ends are wired the same way. Now let's see the practical scheme and the wiring diagram of this project. Below we have the two RJ45 plugs, the plug connections to the respective Arduino ports and the LCD display connections. From here we see the equivalent wiring diagram. Let's see the sketch of this project. So, let's put the wiring diagram on the left for convenience. And here is the first part of the sketch. First of all, the only library that we have to include is the liquid crystal, while in this other part we define all the labels corresponding to the pins that we will need to interface with the display. Here instead the connection of the pin to the display, through the labels. In this other part we define these two arrays, with the pins corresponding to the connections of the RJ45TX ports plug and the RJ45RX ports plug. Here we start with the setup, where we initialize the 16 by 2 character display. Here instead through this cycler for we set all the outputs in the TX port as output, we put them at a high level and we put the pull-up resistor. Now let's move on to the loop, where through this 2 by 8 array of integers, we store the correspondences between the TX and RX pins. In this double cycler for, one for TX and one for RX, I do the mapping. In practice I set the current pin as output and send a signal on the current TX pin. At this point, if there is a signal on the RX pin, then I save the index corresponding to the TX and RX in the 2 by 8 array I defined earlier. In this double cycler for, one for TX and one for RX, I do the mapping. In practice I set the current pin as output and send a signal on the current TX pin. At this point, if there is a signal on the RX pin, then I save the index corresponding to the TX and RX in the 2 by 8 array I defined earlier. In this second part of the sketch, through this cycler for, I'm going to check the content of the second row of the 2 by 8 array. If inside there are values equal to 0, it means that a correspondence with the TX has not been found for those values. In that case the X is stored inside the RX string, otherwise if a match with the TX has been found, the corresponding connection is placed in the RX string. At this point, on this last part of the sketch, let's move on to displaying the data on the LCD. So after clearing the display, placing the cursor at position 00, we print the first line with the TX string and the 8 corresponding pins. Here we pass to the display of the second row, with the first part of the header, the array X equal, and then the value of the match is found and stored in the previous part. In this last part, the string corresponding to the type of result that gave control of the cable is shown on the display. Therefore, if the sequence corresponding to the cross cable is recognized, the wording cross cable will appear on the edge of the display. If an identical match to that of the TX end is found on the RX line, pin 2 pin will be displayed, which corresponds to either 568A or 568B. If, on the other hand, the correspondence we find is from 8 to 1, it means that the cable wiring has been done in reverse and therefore the wording in cable will be displayed, i.e. cable reversed. In the latter case, which may be the case in which no correspondence has been found, it means that the cable is not connected to any pin and therefore all connections are interrupted, but a malfunction could also occur if one of the 8 connections is absent. Then, in that case, we would find an X corresponding to that connection. In the latter case, in which we should not find ourselves in one of these 4 conditions, a partial cable would result, i.e. with 1 or more missing connections. At this point, after a 1-second delay, the loop starts again. Now let's move on to testing and checking 3 different types of cables. Let's go feed. First of all, the TX line is displayed, where there are the 8 corresponding pins of this connector. Now, since there is nothing connected, the XS accompany the second line because no match has been found and the wording on the right no cable. Let's check initially with a cross-type cable. We put one end on the TX side and the other end on the RX side. The correspondence of the pins on the RX is instantly displayed, where we see that the 1 of the TX goes to 3, the 2 goes to 6, the 3 goes to 1, 4 and 5 instead are also direct correspondence on the RX, the 6 with 2, 7 and 8 are directly connected. Now if I connect one end, the XS are instantly displayed on all lines of the RX. So in no time at all a cable is checked that otherwise would have required much more patience. Now let's check a 568B type cable, therefore a standard category 5 OTP cable. We connect on the TX side and make the corresponding connection on the RX. At this point, since both the 568A and 568B are pin-to-pin but have a different color scheme, we will see direct pin matching, so 1 with 1, 2 with 2, 3 with 3 and so on up to 8 and the wording pin to PIN. However, this tool does not tell us if we are testing a 568A, a 568B or maybe a normal pin-to-pin cable without the twisted pairs. However, starting from an OTP network cable, we can check whether it is connected correctly or not, or if there are any broken lines. Now let's go and do a different type of test, that is, with little sources we're going to connect the TX lines to the corresponding RX lines. Here we have pin number 1 of the TX connected to 8, in fact here we see 1 and 8. We are going to make other connections, here we are now on 5 and we are going to connect it to 7. No, it's not 5, it's 4, 1, 2, 3, 4 and appears on the penultimate which is 7. In fact we are going here to check the 4 with the 7. Let's connect the others too, here we have the 8, so we will see it appear. Now I connect it to the 1 under the number 8 of the TX. A decalo here. Now we also continue with the others until all 8 lines are exhausted. Let's go to the 7 and connect it to the 6. And in fact 7 under a 6. Now let's go, the 6 is still free, let's connect the 6 and put it 8, 7, 6, 5. To take the 2 of the TX and connect it to the 2 of the RX. And here you go. Obviously in this way it is not easy to connect, but you can think of a more professional, improved, boxed version, perhaps with a small PC made to house the 2 RJ45 connectors, the Arduino MEGA board and the display. In some points it really becomes a very comfortable and practical and also portable wheat. Well, at this point I'd say we're done, and if you liked the video, subscribe to the channel and leave me a nice like, and if you want to receive automatic alerts every time I upload a new video, click on the bell too. Now goodbye and see you next time. Hello and have fun.